Okay, so now we're in the first section of this chapter, how the internet works. If you're new to this channel and you would like to follow along with the curriculum, it is free. The link is in the description. Let's get into it. How the internet works. Most people use the internet without fully understanding how it works. Again, the internet is like the abstraction. All people care about that it works. That's what abstraction is basically about. All I care about is that it works. And most people, before you became a software developer and started learning this process, going through this process, you didn't care either, I'm sure. But now that you are becoming a software developer, understanding how to think like a software developer, now you want to know, how does this work? Now, without much trouble, they can open a browser, navigate to a site, and interact with it. They do not need to know precisely how the internet works in order to use it. For web developers, however, fundamental understanding of the flow of information across the internet is essential. Keywords here: how the flow of information, and that it is essential. We need to understand how this works when we are building our software or our web application or our websites. Servers and clients. The internet uses the client-server model. A server is an application that provides resources such as raw data, web pages, or images. A client is an application that requests resources from a server. Now, we're starting to introduce you to understanding how the client-server model works. The client side of what you've been learning about with the HTML is what you see on the browser. The server side is the back side, like when we get into Java or Node.js. Those are the things that's happening behind the scenes. And everything that we're doing here, this whole web page that we're looking at right now, is what we call client side. This is what the client sees. Now, when navigating the web, the client is the web browser on your computer or smartphone. When you click on a link or type in an address and hit enter, the client browser makes a request to a server that sits in a building somewhere out in the world. The server receives the request and sends a response back to the client. The client then displays the content of the response. And this is just a little illustration how this works. Understand, a server is just really your computer. A laptop can be a server. Your desktop can be a server. They look like boxes that's somewhere in some type of center that has, especially for Google, probably have millions and millions of these servers to be able to service all their clients worldwide. And it's good to understand how this process works, because you're better understand how cloud computing works when you get your head wrapped around how the client server model works. Now, several clients communicating with the server. These laptops are considered the client, because this is what we're using to be able to see what it is that we're looking for. But what we're saying is that when a user comes to this computer or to their laptop or to their phone, they request information. That request gets sent out to the server. The servers then process it and then send it back. Now, that's just high level. We're going to go a little bit deeper than that, and it is much, much deeper than that, but that's just the premise and a high level of what this is. Now, in the client-server model, the server may sometimes be on the same computer as the client. This is often the case when a programmer builds a web application. For instance, localhost. Localhost, when we're learning how to build our web applications, we're building it using our localhost. That's our local IP to be able to see things in the browser, to be able to use the browser is through our localhost server. The in-progress development version of the application is on their laptop, as is the browser that they use to test the app. Now, we're going to talk about protocols here. Don't get confused with protocols versus prototypes. Here, a protocol is a standard for communications between computers. Most web communications uses three protocols, in fact. Here, you're used to this one, HTTP, because you can see that in your browser. We can see that up here. You can't see it right here because it's kind of blocking it out. But HTTP colon forward slash, and then it gives whatever the address of the actual domain that you're trying to reach. But it's important that you kind of understand what these protocols are because you're going to use them. You need to understand TCP over IP and DNS. So when you go through and read the full name, Hypertext Transfer Protocol, that's what HTTP means. When we get the S on the HTTP, S, that means the S stands for secure. Now, TCP, Transmission Control Protocol, Internet Protocol. Now, if you read the role here, we understand that the HTTP is the high level. Remember, when we talk about high level, keep it in context. Here, we're talking about the client side when we talk about the high level, where we as humans can read it. And high level web communication for transferring files and information, including HTML, CSS, JavaScript files, images, and other media form submission. But the TCP over IP is a low level web communication for transferring small chunks of raw data known as packets. Make sure you understand that because, again, you may have to work on the cloud. You need to understand what this packet means. And so years ago when I first started learning before I became started learning about software development, I was trying to understand how to become an online marketer. And so many people are always trying to sell projects and programs and everything, and you came across these packets and how it worked, and a lot of the people that were selling their programs, they were trying to make it sound like they were gurus, but really they didn't know what they were doing either. And so a lot of this terminology was introduced to me back then, especially when they talked about web scraping and all those things. Before I became a software developer, I would run across this term packets. I didn't understand it then, but it is good that we're introducing it to you now. Remember, this is a seed. The more you do, the more you're going to improve. So the more and more you go over this, the more and more this is going to make sense. And then DNS is for domain name service. Translates human-friendly names into a server address, like for instance launchcode.com. That is the domain, but really it is translates that name and it gives you a special IP address. You can do this, find this out by using a lookup in your Git bash and everything, and we'll play around with that later, show you how to figure out what the domain or the server address is for a particular domain name like Google. So we'll use a terminal. You can figure that out. A thorough understanding of each of these protocols is well beyond the scope of this class. However, as a web developer, it is important you have a general understanding of the roles. Each protocol has a different and critical job in enabling web applications. Like I said, HTTP. HTTP is the most important protocol for web developers to understand, which you may have guessed from the title of this chapter. It specifies how requests for common web data such as HTML files or images should be structured, as well as a response to such requests. The details of request and response messages structure are the topic of the rest of this chapter. And so HTTP, understand, it's the protocol. And like I said, we're just planting a seed for this, because as we go deeper and deeper, especially when we get into React, you need to understand how the HTML document files work, how we're going to use images. So understanding all of how HTML works is very important, because we're going to be using what we call JSX in React. So here HTTPS refers to the HTTP protocol use what they secure. So the S stands for secure connection. And years ago, Google, to protect people's information, they started requiring that you needed a HTTPS in order to get your website indexed. If you don't have the S on it, that means it's not secure and you're not going to get indexed. So it's important when you create your own web applications is that you use HTTPS, which you need to have a certificate, which is a SSL certificate, which we'll kind of talk about that a little bit more later on. A secure connection encrypts so that it can't be read while in transit. This is where those packets come in, because a lot of the time when we're making requests, it's going across the internet highway, and they can easily be picked up by people that have bad intentions. So by using this secure protocol, it can't be read while in transit. This is a problem right here, that it was easy to basically hack an HTTP website, but now with the HTTPS, it's a little bit harder. The reason why a lot of times sites get hacked most of the time is because of a human error, because somebody didn't update something, or somebody didn't do their job. So it's in a lot of the time the way things get hacked is because of human error most of the time, because there's a lot of fail safes out there. If you follow those fail safes, you have a much better chance of not being hacked. But you need to understand how this works. So the data is encrypted by the server client before being transmitted, and decrypted once it is received by the client server. Now, the precise detail how such encryption works is beyond the scope of this course. So you can go a little bit deeper by understanding how that works. We'll touch on it. I'll touch on it a little bit as we go further in the course, just to kind of get your mind ready to receive that information. Now, TCP over IP is a low-level protocol that is quite complicated. For our purposes, it is important to know that TCP/IP is the standard that allows raw data to get from one place to another on the internet. So that's the basic form of what it means. It's a lot deeper than that, but we're just giving you a high-level understanding. Now, when a server sends a file back to a client, that file must physically be sent across a series of network components, including cables, routers, and switches. Files are broken down into packets, small chunks of a standard size, that are individually sent from one location to the next until arriving at their final destination and being reassembled. So what it's saying is the information that you're requesting is broken up like a puzzle. It breaks all the pieces of a puzzle up. But then what it does is it puts it all together, back together when they're returning the information back to you. Now think about it like this: in Star Trek, when a person is being transported to a different location, what it does is the machine breaks down their molecular body framework and put it in little bitty pieces, and it sends it over to the next location through whatever series of transporters or however they use it, but it reassembles the person once it gets to the final destination. Back when that first came out, that was just unthinkable. We didn't understand it. People didn't understand computers. Whoever were writing for Star Trek back then in the 60s, I think it was the 60s or the 70s, that either already understood some of this stuff already, or they was way ahead of their times with that, with Star Trek and then Star Wars. But nowadays it makes sense to us now. Back then, boy, it was mind-blowing, some of the stuff that they were talking about. Now, you can think of the internet as a series of tubes. This phrase was used by a U.S. Senator in 2006 and widely mocked. However, we think it's actually a reasonable analogy. TCP/IP allows data to pass from one tube to another until reaching the final destination. Now, DNS, this is something you definitely want to understand. We're going to break this down to you right here. DNS is the address book of the internet. It enables us to use readable and memorable names for servers such as www.launchcode.org or mail.google.com. Such names are called domain names, and they function as aliases. Make sure to understand this is just the alias right here, but really there is an address that's up under it. So, you think about this. When you think about your house where you live at, we have an address for your particular house. You have a number and the name of the street, the number and then the name of the street. But really there's an actual location that is given in numbers to find your location that can be used. That's how Google uses to map out everything, and that's how they got the information from people that were sailors, pirates, and back in the day when they was selling ships to coordinates. And there's actually a coordinate for your particular address. You don't see that, you don't know that, but for in the mail carrier, we need that address for human readable, so the mail carriers can find you, and people that's trying to send you mail can know how to send you the information that you're looking for. When you buy something online, you have to give them an address, but there's an actual number associated with where your house is located. Now, every server on the internet has a numerical address known as an IP address. When a message is addressed using a domain name, the corresponding IP address must be determined before it can be sent. So here, the IP address of launchcode.org and mail.google.com these are the addresses right here. These are the IP addresses for each one respectively. You can actually find this information by using your terminal, and we'll show you how to do that too as a test. Matter of fact, I think we have it here in the notes here inside the curriculum how to do it. Now, sending computers will attempt to resolve the domain name by looking it up on a name server. Understand what a name server. So when you go and buy your domain name, it has a name server. So that means this is what's going to connect your information, your domain name, with your IP address so it can be found on the web. A name server is the directory of domains and IP addresses, and there are thousands of them on the internet. Most internet services provide, such as Charter and AT&T, provide DNS servers for their customers to use. Once the sending computer knows the IP address, it can send the request to the correct server. Now, it is easy to look up an IP address of any domain name, usually freely available tools. Use the popular site MX Toolbox to look up the IP address of launch code. So click there and then look up the IP address. Every computer uses a special IP address, 127.0.0.1, to refer to itself. This is known as the loopback address, and it often has the alias localhost. That's what I was telling you earlier about localhost. When you're working on your server, and on your computer, when you're building your applications, you need a server to be able to put a HTML document on the web, and localhost is your local server, and this is your actually IP address for localhost. If you use the loopback address, and remember that name, loopback address, when making a request, the request will be sent to a server on the same machine as the client. Now, when we talk about the web addresses, when a client requests a resource from a server, it does so using a uniform resource locator, URL. You're familiar with this. URLs are also called web addresses. As a regular user of the internet, you are already familiar with the URLs like these. So you're already familiar with these 1, 2, and 3, the launch code, Wikipedia, and DuckDuckGo. Some of you may not use DuckDuckGo, but it's definitely a web browser that you can use, or it goes to a web browser. A URL encodes a lot of information about the request, including what is being requested and where the request should be sent. URLs are made up of several components, each of which plays a role in enabling both client and server to understand what is being requested. So we generally work with URLs with this structure, like so. You have a scheme, then you have the host, you have the port, then you have the path. We are learning about paths, right? And absolute path and relative paths. And so we have a path. This all means something up inside your search, not the search bar, but the address bar up here at the top right here. So 5 components of this URL are the scheme, the host, the port, which is optional, the path is optional, and the query string. These 3 are optional, but these right here are required, the scheme and the host. A property form URL must have these components in the exact order shown here. Only scheme and host are required. Let's look at each of these in detail. We have the scheme. The first portion of the every URL specifies the scheme. Common schemes are HTTP, HTTPS, FTP, and mail to. These are schemes. Remember this because this is you got to be able to put this together. Remember that these protocols are schemes. We call them protocols, but we call their schemes. And file. Most often the scheme specifies the protocol to be used in making a request. For us, this will always be HTTP or HTTPS. If left off, a web browser will insert the scheme HTTP/S for you. So by default, it's going to add it because you have to have it. You can't do a lookup or look back without the scheme. So the scheme is always followed by : // The host portion of the URL specifies where the request should be sent. The host can be either an IP address like 104.25.128.113 or a domain name like launchcode, www.launchcode. And then we have the port. Following the host is an optional port number. While the host determines the server that the request should be sent to, the port determines the specific application on the server that should handle the request. This is important because a single server may run several applications capable of handling a request. Ports definitely are important, especially when you're dealing with databases. You're going to need a port. Localhost has a port. For it to be on it has to have a port to be able to be seen on the web browser. We will use localhost 3000, localhost 5400 or whatever, but it needs a port. And you may set this port up to be to host your domain or your information that you want on the web. But you're going to have some type of port. Now, conventionally, a given type of application will always use the same port, though this is not a hard rule. For example, web servers typically use port 80 or 443. The regular encrypted messages, respectively. On the other hand, MySQL database typically use port 3306. It's important to understand those because you're going to use them. Example, suppose a server at mydomain.com is running both a web server and a MySQL database server on the standard ports. Requests to mydomain.com :80 will be given to the web server, while requests to my domain name :3306 will be given to the database server. Notice here we said database server. You're going to have multiple servers doing multiple things. So understand how this works, what that port means, because that means you're going to have a port maybe going to different things when we build out a full-scale web application. If a port number is not specified, then the default value based on the scheme is used. When using HTTP : // the default port is 80. When using HTTPS : // the default port is 443. Now let's talk about the path. Following the domain, an optional port is the path, which consists of a series of names separated by // The path provides information that tells the server what is being requested. It can consist of a series of names such as /blog, /entries, /2018, Now sometimes we will call it just the root too, if it's just one /, or it can be in with the explicit file name such as blog /index.html. Example, a request to https://www.launchcode.org/blog/ as the resource that lives at the path blog on the server for launch code. This resource happens to be the home page of the launch code blog. A request to the very long URL below asks for the launch code logo, which lives at the path right here, assets. And we're learning how to use this when we're building our web applications. You know that we have to have a path that we're using to get information. So for instance, in your file, if you have an assets folder, and this is where the inside the assets folder is where this image is, you got to make sure you give that relative path. This is what we call the relative path. You remember what the absolute path is? Put the information in the comments below if you do. If a path is not specified, then the root path, I was telling you about, if it has just has one / is used. The root path typically refers to the home page for a given site. Now we have the query strings. Following the path is an optional query string, which begins with a question mark and contains a set of key value pairs. Pay attention how that looks. So here we have a question mark contains a set of key value pairs. Each pair is joined by an equal sign and is separated from the other pairs by an and. For example, the query string of a search on DuckDuckGo.com looks like this. You have the query string starts with a question mark when you see that, and then it has this Q, which is the key, and then this is the value right here. So it has the key value pairs, and it's separated by that equal sign, and then it has this and right here, what else is being added to it. So make sure you understand this, because when you start looking up into your browsers, you start seeing how this works. It makes sense to you when you can start identify, oh, this is a query. I know it's querying something. And this is going to help you when you start learning about databases. This query string has three key value pairs. The Q, which is for launch code, ATB, which is this number right here, V1667-5. So you're able to separate these. You can see that they're the keys, and then this and is separating, letting you know that there's different. It's like almost like a comma, basically, the separator to let you know that these are different, but you have to have the and in there. So make sure you pick up on this, because sometimes those queries can be kind of long. And then the IA web. So here this and it separates all three of these parts. The query starts with the question mark and has three queries there. Now notice that these pairs are separated by and in the query string. While the path specifies what the request is asking for, the query string provides additional data that may be needed to fulfill the request. As an analogy, you can think of the path like a function name and the query strings as the function arguments. Now put it in all together. We just covered a lot of information. While these nuts and bolts details are important, they aren't nearly as important as the high level picture of how we access resources on the internet. To tie these ideas together, watch these two videos on URLs and the internet as a whole. So we got two videos here. Make sure you watch these. Then we have check your understanding. Okay, this is a long video. I apologize for that, but I didn't want to stop. I wanted to kind of get through it. So this is one of those things you're probably gonna have to take a break from watching it, which I'm telling you this at the end of the video. But again, this is the end of the video. Remember, the more you do, the more you improve. See you in the next section.